Good morning, thank you very much for coming along and thank you for giving me the opportunity to speak to you this morning. So yes, I'm going to give a brief presentation on energy use at the UEA campus, how we generate it on campus ourselves, the impact on our carbon footprint, and a bit more about the wider biodiversity and sustainability on the campus. First of all, I'd always like to start with this picture of our main campus. It's a couple of years old now, but it gives an idea of the focus of the campus. It's very easy to forget that we own all this 360 acres of land down this side of the campus. The campus used to be a golf course till the university was built on it, we've planted a lot of the trees. We've even dug out the broad ourselves and created a lot of the biodiversity and the habitats around the campus over the last 50 years of the university. So we're trying to achieve an exemplar low carbon campus, that's the vision, and we've set ourselves a number of targets to try and achieve over these years, and the presentation seems to be going extremely slow, which I can only apologise for. There we go. So, main headline target to reduce our carbon footprint by 35% from 1990 levels by 2020, which is in line with the UK's national target. We've also set out to implement an environmental management system. And over the years, we've gone through a programme called Eco Campus, which has bronze, silver, platinum stages. And then finally, in May 2015, we achieved ISO 14001 for the whole university, which is a fantastic achievement. We've also tried to reduce our water consumption. And it's reduced by 10%, and we achieved that target in 2013, and we've now set out to improve that even more. And we're also trying to divert 75% of landfill from waste. Again, we've achieved that, and we're now looking to improve our recycling rates. All our general waste goes to an incinerator down in Ipswich. That's what happens to Norfolk's waste now. There aren't any landfills left in the county, so everything's now incinerated. Hence that target of diverting from landfills become kind of irrelevant because we have no choice. It can't go to landfill anymore. Okay, so moving on a bit more onto our carbon footprint. So you're going to be doing a carbon footprint of your own lives, which is something I find quite interesting. Not everyone's cup of tea, but there you go. That's why I'm in this job. So carbon footprint of the university. So this one is the numbers I'm going to put on here are for the buildings on the main campus, and for the vehicles that we own. There's other parts of the emissions that aren't included in this, such as refrigerant gas escapes and water and waste. But we do report them, but they're not in these figures that I'm going to show you now. And it will show you a mixed achievement. So, 1990, 19,250 tonnes. I can't tell you how many balloons or buses or whatever that's equivalent to, but there we are. And what you'll see is from 1990, it's increased to 22,000 in 2005-06. It was still 22,000 in 2010-11. It dropped a little bit in 2011-12, and then has bobbed around up until around here. And then last year we had a bit of a situation in our main boiler house. We had to close it down to replace the old 50-year-old boilers, which is a great thing. It's going to save lots of energy and carbon in the future because the new boilers are 91% efficient compared to the old ones being 75% efficient. But it meant we had to take our CHP, our combined heat and power system, offline. I'll explain more to you about that, but that's the reason why we had such a significant uplift in our carbon emissions in that year. What this fails to show, and I think this chart shows it a little bit better, is our carbon intensity. Over that since 1990, the campus has doubled in size. We've gone from 3,500 students to nearly 15,000 students, and we've gone from 120,000 square metres of building up to nearly 240,000 square metres of building. And our carbon footprint's gone up by a little bit. And that's down to have the work we've done. We set out on a strategy years ago to build low energy buildings, which we'll come on to in a bit. And they have meant that we've been able to keep our carbon emissions steady whilst rapidly expanding the campus. So energy demand at UEA. So electricity. So we use electricity for lighting, for office equipment, for cooking, for research. We use about 3 megawatts overnight, 3 megawatts per hour overnight and at weekends, and 5.5 megawatts during the day. So that's 3,000 kilowatts. And obviously a kettle uses 3 kilowatts. We use for heat, for space heating, for domestic hot water, for the sports park pool, and temperature-controlled research environments. Again, we have a lot less heat demand in the summer, only a megawatt, that's just for hot water around the campus. And we use up to 12 megawatts of heat in the winter. Most of that's going into the teaching wall. And you still probably don't appreciate it most of the time. Okay, so again, this is now just telling us how much we use. So over the year, 35 million kilowatt hours. And for heat, we use about 45 million kilowatt hours. So they're quite big numbers. We also use some cooling for lab equipment. So, how's that changed? So again, this highlights how our main electricity on the main campus has changed. The red is what we generate on campus ourselves. Blue is what we import, and you can see here 2014-15. Yeah, we had a bit of a blip while we had to turn them off, and so we generated a lot less. We normally, around here, we were generating about 68 to 70% of our own electricity on the main campus, and it's dropped down as low as 25%. And obviously you can then see the implications on the cost of buying our electricity in. So normally, we have been spending around £1 million buying it in. When we had to shut the CHP on, we had to find an extra £1.7 million to do that. So our main heat, sorry, just before I finish, you'll also see there again how that's increased. What you need, round about here, this is where Inter and the Coleman group of residences were built. Round about here we built Thomas Paine, and then round about here we bought on Crome Court. So there's lots of buildings that have gone up, and actually you can see electricity use is just starting to tail off at the far end. We're actually starting to use less. Heat's a bit more erratic. Are you going to cover degree days in your course at all? No, okay. Good, you'd be saved from the joys of degree days. For your benefit, it's an illustration of how cold it is and how much time we have to heat. I'm not going to explain it in any more details than that, but I've plotted it along here to give you an illustration of how much heat we would expect to use. So that's what you see, that our heat demand is very much in line with the weather. So the colder it is, the more degree days, the more heat you need. And so that kind of maps out where it is. And this chart just explains where the heat's coming from. The red's the boiler house, the purple's from the biomass centre. Okay, main campus gas. Now most people doing a carbon footprint will be really pleased to see a reducing gas use, but for us that means we're not using our natural gas-fired CHP, which has then had a negative impact on our carbon footprint. And you can see our costs have dropped, but not as much as our electricity costs went up. So it has cost us quite a lot of money not having our CHP on board, and it also has impacted on our carbon footprint. So yes, this is our gas use, and this is where we generated most of our own electricity. 2009-10, that was our peak year for self-generation, that's 69%, and so was 12-13, and you can see that reflected in our gas use. And the big drop in price between 10-11 and 11-12 was when we changed our gas contracts, and it's dropped the price quite significantly. And the price, for those who are interested in the commodity market, is still falling. And something like the pence per kilowatt hour in 9-10 was around about 3.5, 4 pence per kilowatt hour. At the moment, the market report yesterday was about just under 1 pence per kilowatt hour. So significant drop in gas costs. So CHP, combined heat and power. This is a picture of the newest of the 4 CHP engines we have on campus. You can see the person standing there delivering it to get you an idea of the scale. And if you go on the campus tour next year, you'll get to go in and see that operating. So that generates 1,700 kilowatts of electricity and 2,300 kilowatts of heat, and uses quite a lot of gas. It's using 5,500 kilowatt hours 5,500 kilowatts per hour. But again, it massively reduces our carbon footprint compared to using the national grid. And so the heat from this engine goes into our district heating system. So all but 5 buildings on our campus are heated by district heating, and they use so 5 buildings, which are Constable Terrace and Julian Study Centre and Med Building and Elizabeth Fry. And they were a group of low energy buildings that didn't justify putting the pipework in at the time for each one individually. Collectively, it may have been a different decision, but because they were built piecemeal, they weren't connected in. If we put another building down where CD Annex is, the porter cabins, then we may connect all those buildings up in one go. So again, this is a schematic of it. You can see where the efficiency is generated. So 50% roughly comes off as heat, 36% comes off as electricity, and the rest goes up as flues and cooling the engines. So compared to a coal power station, which runs at about 36% efficiency, with most of the heat being put up the great big chimneys, this is 86% efficient and much more cost effective and carbon effective. One thing you'll see being delivered next weekend is 2 thermal stores, which you might just be able to see in the background here. And we're putting these in to maximise the efficiency of our engines. At the moment, overnight potentially, we can't use all the heat coming off the engines. We have to reject some of it to atmosphere. So what we're going to be doing is putting 220,000 litres of water, which will heat up to 90 degrees overnight. And then instead of having to fire boilers the following morning, we can just bring the heat out of those. And this is our absorption chiller. So this uses waste heat from the engines in the summer to produce cooling across the campus. Again, we've got a district cooling system which runs down the teaching wall down to Sainsbury's Centre. Quite a useful piece of technology. It's not particularly efficient. You know, an electric chiller is about it's got a COP, which is the power to heat ratio of about 3.5. So for every kilowatt hour of electricity you put in, you get 3.5 kilowatt hours of cooling out. This is only 0.7, which seems a bit silly, but if we weren't using the heat in that, then we would be rejecting it to the atmosphere so we could run the engine. So it's just using waste heat. So what have we done to try and save energy? As I mentioned earlier, we've been trying to reduce our energy consumption by building efficient buildings on campus. Elizabeth Fry was the first one in 1995. That until recently, because the boilers broke, they were 18 years old. They ran off 3 domestic-sized boilers. Who lives on the village on the campus? Anyone live on the village? Yeah. So this building, 3,500 square metres, had 3 boilers like you've got in your kitchen. And it generally only used one of them to keep warm. It's still one of the most efficient buildings on campus. Yes, when they did a buildings review of it, it came back as probably the best building ever. For those interested in the numbers, it uses 35 kilowatt hours per metre squared per year to heat, compared to the teaching wall, which uses about 180 kilowatt hours per metre squared to heat. So we then moved on to build the medical school and ZISA, and ZISA was our first attempt at putting some PV on here. It was a little bit of an experiment. The PV's in the glass window. Have you been to see that yet? Okay, so and it's quite interesting to see that this is the difference in the efficiency between the vertical and the angled. The angled makes a big difference. It produces a lot more electricity. But that produces about 19,000 kilowatt hours per year from about 34 kilowatts peak system. 19,000 kilowatt hours, the site uses 35 million kilowatt hours. It's not going to solve our energy solutions with that system, but it's a great contribution towards it. We then built the Edith Cavell building over at the hospital, the Thomas Paine Study Centre in 2009, and finally the Julian Study Centre. The Julian Study Centre is a change from all the other low energy buildings on campus. It's the first step in our change. All these ones are high thermal mass buildings, lots of concrete, wrapped in insulation. Thomas Paine in 2013, the district heating system between the Estates building and and Thomas Paine, there was a leak on it. We had to shut it down. We shut it down in March. It was -10 outside, and we had to shut it down for 2 weeks. We turned off the ventilation, and we had no complaints. Nobody moaned. No, we didn't have to install electric heaters. The heat from the computers and the people in there kept the building sufficiently warm. The reason why we have to provide heat in there is because we also have to change the air, and that's the only reason why we have to provide heat. Julian Study Centre is made of wood. So it's a wooden structure, cross-laminated timber. All the frame is a wooden frame compared to a concrete frame. We still have the thermal mass, so it's got concrete floors held up by a wooden mass, which is we're trying to reduce the embodied carbon footprint of the building. This also has PV on the roof of it. You can't see it from the ground. This has a 20 kilowatt system compared to Zeiss's 34 kilowatt system. And this produces 22,000 kilowatt hours of electricity compared to 19 from Zeiss, which goes to show that in the 10 years from Zeiss being built to this being built, how much PV has improved in its efficiency. And then we go on to the All Singing, All Dancing Enterprise Centre. Completed this summer. This is completely wood, built to a passive house standard, which means in all intents and purposes it doesn't require any heating at all, and massive south-facing windows to try and capture all the light, and it also has 49 kilowatts of peak of PV, which we would be expecting to produce around about the 55,000 kilowatt hours of electricity per year. We've also done some really boring things, but quite important. So this is one of our district heating mains. This is an uninsulated pipe works insulated, but the joints and the valves weren't insulated, so we put some covers over the top of them. Surface temperature dropped from 76 degrees to 16 degrees by putting that on, and saved 92 tonnes per year of carbon by doing that across the campus. Now just got to make sure the maintenance guys put them back on whenever they do any repairs. All of our buildings on the campus are controlled by, I think, called our Trend system, which is a building management system, and that controls the heating and the ventilation across the whole campus, and also controls the district heating, turns pumps on, turns pumps off. Really useful to understand how our buildings are performing and be able to improve the energy efficiency of them. And yeah, when someone complains that they're hot or they're cold, one of the first questions is, go to the BMS, is there a real problem? Has something stopped working on there? We can look on there and see if any of the buildings have stopped working, try and reset it, get it going again, or we can try and diagnose what the problem was. So this is just an example of just how much electricity we use. The typical UK house uses 3,300 kilowatt hours per year. Biology uses that by 2 o'clock every day. To give you an example of it. The other thing that Catherine has recently discovered, and I'll get this wrong, is 27 minus 80 freezers. So there's 27 minus 80 freezers in biology and a little bit in BMRC. They use the same as those 27 freezers use the same as 36 houses per year for electricity, just to keep things cold. So and also the difference in the surveys found the difference between the worst ones and the best ones is sort of 4 times, just because of the age of them. So yeah. So a bit onto our engagement side of it. So Carbon Crew and Sustainable Ways. So for the staff, we're branding all of our engagement UEA Sustainable Ways. And for the student side of it, it's the Carbon Crew, which you may or may not have seen branded about. And these are badges that we use to communicate to our staff and our students. And this is a little picture of Catherine's wonderful website that she's put together for us. And there's lots of information about all the different things we're doing across the campus. So if you ever want to find out anything, go on there, have a look around, see what you can find, or give Catherine a call, and she'll probably pass it on to the relevant person. So this is a thing called Controlling Power at UEA. This is a new thing we put in about 2 years ago. There's no real carbon or environmental benefit from it per se to us. There is a financial benefit, we get paid for it. But you may have heard on the news recently a lot of concern about the UK running the power stations not being able to provide enough electricity in peak time. Well, this is how we're helping to contribute to that. There's a little thing, a company called Open Energy, and they control all of our air handling units across campus. And if the grid's starting to get a little bit short of electricity, it will turn things off, and if you start to have too much electricity, it will start to turn things on to generate electricity. The idea is it doesn't use the average is we use the same amount of electricity, we just use it at different times, and the idea is that within 2 seconds of the grid starting to move out, it works on the frequency of the electricity. As soon as 2 seconds of the grid starting to move out of the prescribed zone, this piece of software will kick in and start turning things on and off across the whole country to try and bring the grid back into balance without the need to turn on a power station or have one sitting in idle. Energy future. So there's lots of things that are coming on in terms of the future. The environment is obviously a huge one with the government's the commitment to limit temperatures to 2 degrees with a hope of 1.5 degrees. It's a fantastic achievement to get that agreed. There's lots of carbon taxes that are in place. There's the European Union Emissions Trading Scheme. There's also pollution. And the cost of energy, which are also highly variable. At the moment, there's a massive drop. Oil prices have fallen down, coal prices have gone through the floor, and there is just a massive change. But the reasons for that is the standard message is that Saudi Arabia is trying to price fracking in North America out and make it go bust. But there's a little slight divergence on that in last May, I think it was, the oil minister for Saudi Arabia had a fantastic quote, which I've not got here, but I was sure to bring it with it, which was, Saudi Arabia, we can see the end of fossil fuels as the primary source of energy in the world in the next 30, 40 years. So they've twigged that in Saudi Arabia, they've seen the end coming, that they're not going to be able to sell all their oil and fossil fuels, and they're investing heavily. They've set up a university that's entirely dedicated to PV development and international distribution of energy, electricity. You can kind of see how their mind's working. So the other thing is infrastructure replacement in the UK. Infrastructure is coming to the end of its life. Another coal power station announced was going to close at the end of this year. So there'll only be about 8 left in the UK by March. So that's going to have a massive impact, not just on our carbon footprint, but also the need to build more energy infrastructure. But one of the cost implications for that is that the actual cost of electricity, I can buy it off the market for about 3.5 pence at the moment, but it still costs 9 pence to get it through the door. And the rest of that cost is the cost of charges of building all the new infrastructure to get it from the power stations to here. So increasingly, it's going to be better to generate locally, distributed generation, rather than buy it from the grid. The grid will be there as the backup. And security of supplies as all these fossil fuels run out. And a lot of this, what I've said, is highlighted in the UEA Energy and Carbon Reduction Programme, which is a document which is online via the website, which you can access. So that's me. Not too many of you yawned, so hopefully you're still awake and with me. If you've got any questions, I'll take them now.
Thank you. Do we have any questions?
Fantastic. See you.
Okay, well,
I have one question. Richard, what is if people wanted to follow us on Facebook, Twitter or Instagram, what would they look for? This is a test.
It is a test. And I'm guessing sustainability.
No, SustainableUEA.
SustainableUEA. There you go. Thank you, Kat.
You're welcome.
There's a reason why we employed Kat to do the communications and not me.
sorry, Kat, do you want to introduce yourself? I didn't introduce you.
That's okay. I'm Katrin. I'm the Environmental Officer. I think I know some of your faces. Essentially, I work with Richard in terms of running the various different programs that get you involved. So if you have any questions, you can email us on sustainability@UEA, and the website is also UEA/about/sustainability. So do get in touch if you want to get involved or if you have any questions about anything else.
Thank you.
Right, thank you.
Okay.
So, Richard, if I may, I have a couple of questions.
Mm-hmm.
You mentioned towards the end of your talk about generating energy locally.
Yes.
And I wondered if there might be any ideas, that if there were any discussions about generating more energy, for example, on the UEA site. something that comes to mind is a wind turbine, but
Yeah.
that might not be feasible. So I just wondered if there were any kind of...
So yes, as it happens, we're looking to increase our self-generation. We're looking to replace the 3 old CHP engines that went in 1999. Replace them in the summer with 2 bigger ones. So instead of having 4.7 megawatts of self-generation, we'll have 5.7 megawatts of self-generation. We've also been looking to roll out PV. We've got around about 120 kilowatts on campus at the moment. There's another 110 going on onto the Into building, and the energy and carbon reduction programme talks about having 1 megawatt of PV on site by 2020. The reason that's such a neat technology is that we can't use our natural gas engines to their full capability in the summer because we haven't got anything to do with the heat. So the point at which we're buying most electricity from the grid is the point at which PV generates most. So that's the target we're going for. In terms of wind turbines, I've not looked into it, but an esteemed colleague of yours, Trevor Davies, commissioned a report a few years ago on putting big wind turbines here at UEA, and they would have to be big because of the valley nature of the site. However, there is a good site, providing we can work out how we could get around the helicopter landing issue. But that would be a better location to put them next to the A47 and the hospital site and supply the whole park, research park from there.
Thank you.
Yeah.
Any other questions? I have another one. If you don't mind. Your earlier graphs showed that little blip in 2014-15.
Which one's?
Around the CHP.
Oh, yeah.
Oh, at the very beginning of the talk.
That's right.
I think, yeah.
For the CO2, or was it?
Yes, yes.
Yeah.
And that one as well, yeah.
Yeah, this one here. Yeah.
Yes. And I just wondered if you could tell us a little bit more about.
Yeah. So we made the decision to replace the 50-year-old boilers. Made perfect sense. But unfortunately, when we did that, we had to turn. It took longer than we expected. We found some stuff in there that meant we had to shut down the entire boiler house for 3 months. And then when we came back to bring the engines back online, because of the damp conditions in the boiler house with nothing running, 2 of the control systems on 2 of the engines have become water damaged and couldn't be brought back on. And then it's taken through to get authorization to buy 2 new engines to replace the failed ones has taken a bit of time to get through it. And that's why our self-generation's gone down, and that's why our carbon footprint went on. The existing engines, the carbon emissions per kilowatt hour for our engines is about 0.32, 0.33 kilowatt hours kilograms of CO2 per kilowatt hour, compared to the grid, which is currently about 0.5. Hopefully the new engines, being that much more efficient, will push our on-site generation down into the high 0.2s and stay ahead of the grid, decarbonising.
Does anybody have any other questions? Comments?
Okay.
May I have one extra question? I have several, but this will be the last one. Do you have any sense then of other activities that are being done on the ground in terms of student residents' behaviours and other activities that are being carried out in terms of making the campus more sustainable, in terms of how it's contributing to your overall aims and vision?
I think the best thing here we'll pass over to Kat, because she's probably more engaged on the student engagement side of things.
Okay. So. Yeah. We have a programme called Living Lab, which is essentially where student projects work on the campus to increase our sustainability. And we've got a couple going on at the moment in residences. One is looking at working with green flats. Is anybody here in a green flat? Fantastic. Essentially, green flats are one of the residence options for first years, and when you applied, you could have applied to live in one. And it's just people that kind of want to live together and live a more sustainable lifestyle. We're looking at how to reduce water use in those areas, and then also looking at how to reduce energy use in those areas, with the ideas that those projects will help inform how all of the rest of the flats work as well. So in terms of the kind of, and answering your question, what we're doing in residences, we're looking at ways to start in quite small groups, looking at what could help generally students who maybe don't do ENF, maybe don't have an awareness of this stuff, how we can then take that out to the wider student audience as well. As Richard mentioned, we've got the Carbon Crew students, which is a society as of this year, and if anybody does have any questions about that, please do let me know. It's not just open to ENF, it's kind of open to anybody, but the idea there is that that's tangible projects that you can do on campus that look at working within estates. So some of the things that Richard was talking about, some of the biodiversity work that we do, some of the water efficiency, waste and recycling, anything you want to do in terms of a project around those, you can do through Carbon Crew students. So that's quite a good way of getting involved as well. In fact, just a shameless plug, it's Go Green Week next week. I don't know if you've seen this, it's on the Student Union Facebook page and the SustainableUEA Facebook page as well. Essentially next week, we've got a week-long raft of activities. All the Student Union catering is going to be, well, there's going to be discounts on vegetarian food, as well as then on Monday there's a meat food market and lots of things throughout the week. So do have a look at that and come and see us on Wednesday, because we're going to be at the World Cafe with Carbon Crew students. And you can find out a lot more on Wednesday next week, 6 o'clock in LCR, the Go Green Week World Cafe. It's a very long answer.
Thank you. Thank you. But we wanted to know that what other activities are also taking place that we could potentially participate in. So thank you very much. Thank you. Okay. Anything else? Any other comments or questions? No? Okay. Well, if you do, please pass them on to me, and I'd be very happy to forward anything maybe to Richard or to Catherine. If there's any other information that you'd like me to put up on our Blackboard site in order to advertise to students, please let me know. And I'd like to thank you both again very much for coming today. Thank you.
Thank you.